To understand today's lesson, we have to first define valence electrons. You've probably heard this term before, whether earlier in this class or in a different science class, but valence electrons are the electrons that are in the outermost energy level. That is, they're the ones that are furthest from the nucleus. So if you had a nucleus, and let's say we've got one energy level there and another energy level here, and let's say there's 2 electrons in this first energy level, but then there's 1, 2, 3, 4 electrons in the second energy level. All we mean by valence electrons is we're just simply counting those electrons that are in that furthest out energy level. So this particular atom would have 1, 2, 3, 4 valence electrons that are found in this atom. Well, you can use the periodic table to know how many valence electrons there are across the groups, the up and down columns of the periodic table. And they really just go in order of these tall columns here, these first 2 columns here and the last 6 columns here. These are the representative elements, but we'll just call them the tall columns. Moving across this periodic table, we know that this first group has 1 valence electron. So every atom down this group has 1 valence electron. In the next group, every atom in that group has 2 valence electrons. Now we're going to skip the transition metals here. They're scary. We'll talk about them another day. But in this third tall column, we have 3 valence electrons. Let's try that again. 4 valence electrons. I'm running out of room here. 5 valence electrons. 6 valence electrons. 7 valence electrons, and 8 valence electrons, with the exception of helium. Right here, helium really only has 2, but that's not a crisis or anything we need to worry about right this very moment. Okay, so just by looking at these tall columns, you can know how many valence electrons are within these atoms. So here it is cleaned up, so I could just pick any atom at random, and you don't even really need to know what atom it is, you just need to know what group it's in. So this guy right here would have 7 valence electrons, whereas this guy in green right here would have 2 valence electrons. This guy in yellow would have 8. This guy in gray would have 3 right there. And let's do one more. What color? Red. And this guy right here would have 5 valence electrons. Now counting these are useful because it lets you draw dot diagrams for these atoms. So I've thrown a more detailed periodic table on the screen. When you go to draw a dot diagram, they're really quite simple. Let's say we want to draw one for magnesium. You just start by putting magnesium symbol, find magnesium on the periodic table, it's right there, and then we can go through and we just saw that this column has 1 valence electron, so magnesium's column has 2 valence electrons. So a dot diagram just represents the valence electrons of that atom, and it describes whether they're paired or unpaired with each other. So all you do is start at the top of magnesium and place 1 dot, then go to the side and place another dot, and we're done. Since magnesium only has 2 valence electrons, we will only draw 2 valence electrons around magnesium. Well, let's say we wanted to pick a different one. Let's go ahead and label these 3, 4, 5, 6, 7, 8, except for helium, but no one really cares about that right now. Let's do chlorine. Okay, chlorine has 7 valence electrons. So we'll start by placing the symbol for chlorine. Start at the top, 1, 2, 3, 4. And now, since we don't have an option, we'll go ahead and pair them up. Here's electron number 5, 6, and 7. So we can very clearly see that chlorine has 7 valence electrons, one of which isn't paired up. Okay, let's do another. Let's erase that. Let's pick a good one. Let's do phosphorus. Phosphorus has 5 valence electrons. So 1, 2, 3, 4, and finally the 5th one will pair up. So we can see that phosphorus has 5 valence electrons. 2 of them are paired up, but 1, 2, 3 of them are not. And one more just for fun. Let's pick boron. Boron has 3 valence electrons, so 1, 2, 3. And that's all it takes to draw a dot diagram.